All right, so here we go. Oh, who made that for you?
I had to make it.
Right.
Bro, and I was just like,
You got to sit there.
Here we go, everybody. First question says, find the angle. This notation, remember, means find the angle. Write that underneath if you don't remember that. Find the angle whose sine is negative root 3 over 2. So somewhere there is an angle whose sine is negative root 3 over 2. So remember, when you see this, you remember it's on this half of the circle. Remember those rules. Go back and look them over. Inverse sine, this guy right here, automatically means we're looking over here. That is a negative number. So what did we decide? If it's a negative number, it can't be in 1, so it must be down here. So we draw our butterfly bow tie. And then we remember that sine is opposite over hypotenuse, right? So we'll put opposite over hypotenuse. It makes sense that we put a negative there, correct? Going down, negative. We know, because we've seen this triangle a whole bunch, that that number is a 1. And we know this angle is, look where it is, so that angle is 60. Now, do not say the answer is 60, because 60 would be up here, right? We want to go down, and since we're going down 60, the answer is negative 60. You guys, come on, we gotta remember something. Negative 60. How about the next one? The next one says, find the angle whose cosine is negative 1 over root 2. Find the angle whose cosine is negative 1 over root 2. Okay? Now, this is a cosine, so it's not this part, it's the top part. So we're going to look here and here. Since that number's negative, it's just like the last one. If it's negative, are you going to put it in quadrant 1?
No.
No, because there's no negatives in quadrant 1, right? So we're going to put it over here. Cosine is what? I got to label the sides here. Opposite, adjacent, hypotenuse. Adjacent over hypotenuse. So negative 1 over root 2, and that's a 1? So that's a 45-degree angle. But please, do not say the answer is 45, because 45 would look like this, and that's not what I have. This is the angle. I'm not going down, I'm going up and around. How big is it? 135. And in case you can't figure out how we knew that, this is 180. If we came all the way around, it'd be 180. We skipped 45, so 180 minus 45, 135 is the answer.
So why is it that, so in the first one,
Because you have to be looking only here.
Yeah.
This is like a wall. Here, this is like a wall, so there's no going down. You have to go up. Here, you have to go either up or down, because you can't go all the way around. All right, number 6. In which quadrant is the sign positive? Okay, so this means the sign is positive. Greater than 0. Positive. And the cotangent is negative. All right, in which quadrant would it be that the sign was positive and the cotangent was negative? Well, let's just talk about this for a minute. Would it happen in quadrant 1? that the sine would be positive and the cotangent would be negative. Would that happen in quadrant 1?
Yes.
Boys and girls, is there anything negative in quadrant 1? No. So when it says cotangent negative, that rules out quadrant 1. It's not happening in quadrant 1. All right? Let's look at quadrant 2. Now, I don't know what any numbers are, but I know this one's always positive, right? What about this one? Positive. What about this one? Okay, so if I did opposite over hypotenuse, would that be positive?
Yeah.
Okay, that one worked. Now, cotangent, let's see, that would be adjacent over opposite. If I did adjacent over opposite, would that be negative?
Yeah.
There we are. It happens in quadrant 2. Okay? All right, now we're going to do some sketching. Do you remember what your shapes look like? You guys thought this was easy when we did it. Do you remember what they look like? We remember that sine looks like this. Cosine looks like this. And tangent looks like that. Now, those are the positive versions. We know we can make them negative and turn them upside down, but that's what they look like generally. So we are going to sketch y equals 2/3 cosine 1/4 x. So tell me. I know a cosine looks like this. I have to label those and I have to label these. Tell me how to label anything. Well, normally, under normal circumstances, this is 90, 180, 270, 360. You're exactly right. That's what it is regularly. But look what I put in there. So that divides, this divides the n number. So 360 divided by 1/4 is 360 times 4. So this is 1440. But if we multiply that one by 4, we have to multiply all of them by 4. So this would be 360, 720, 1080. Check my arithmetic.
That's right.
Is that right?
Good job.
Good job, dog.
So I get paid the big bucks for. Now, what else needs labeled? What goes here?
Oh, 2/3.
2/3 and negative 2/3. Now, over to the side, it says, what's its period and what's its amplitude? Period means length, amplitude means height. All right? You know that. You've done the problem. It's easy. Just fill in the numbers. Easy points here. What's the length? 1440. So your period is 1440. What's the height? 2/3. That's your amplitude. Now, if you think you might get these confused, they're alphabetical. Amplitude comes before period, and H comes before L. So if you just remember, if you need something to help you remember, amplitude is height, period is length. And once you got a graph, those are no-brainers. That's just extra easy points for you. All right, so now we've got a tangent picture. Y equals 2 tan. So you know what that looks like, right? Now, where are these asymptotes supposed to be under a normal circumstance? Negative 90 and 90. That's where they're supposed to be. Have I changed them? No. Because how do you change them? You put a coefficient on x. If you don't put a coefficient on x, then you haven't changed them. Is there a coefficient on x? No. So these are negative 90 and 90. Now what about that 2? What am I going to do with that 2? What? Nothing. Why not? Because I can't go up. I mean, there's no like Copper Hill or anything to label. This curve does not have any height. There's no amplitude. There's no height. Because tangent curves go up forever and ever. Do sines and cosines have height? Yeah, because they're hills, valleys. But tangent has no height. And this is the tricky part. The period is the length. That is from here to here. The length is not 90. The length is this whole thing, which is 90 this way and 90 this way. So what's the length? 180. The period is 180. That's tricky. Because you're used to kind of just looking at this number. You can't with the tangent because it goes both ways. All right, one more, sine curve. Now, if there's one of each on the practice test, what do you think? One of each on the test. There we go. Now, I want to just jump in, because I'm excited about this. I want to just jump in and graph this. That's a sine curve. But what do I have to be careful of? The negative. And what does that negative do to it? Flips it. So I'm going to have a valley and then a hill.
Dad, you gonna take my joke like that? That's how you feel?
Stop it. Alright, so help me with the labels. These labels are supposed to be 90, I'll label them up here. 90, 180, 270, and 360. That's what they're supposed to be. But I've changed that, haven't I? What did I do? I put in a 2/3. That number divides 360. So 360 divided by 2/3 is 360 times 3/2.
Yeah.
So that end number is not 360, it's 540. But if I had to times that one by 3/2, I got to do all these, right? So 3/2 times 90 is 135, 270, 405, double check that, and 540. Yes.
Does this part have a calculator?
Huh?
Does this part have a calculator?
Well, we're going to talk about that. Not a graphing calculator. No.
Okay.
So I may allow you to bring a little calculator, you know, a regular calculator to help with this arithmetic. Okay. Good on that? The only thing we don't have are these labels. We got to get those labeled. What are they?
3 and negative
3 and negative 3. So when we say what's the amplitude, you'll say 3 because the height is 3. And when we say what's the period, you'll say 540 because the length is 540. All right. Now we're going to get out our calculators.
That was clean, boy. Slice and dice.
Okay? And we're going to change something here. We're going to convert to degrees, minutes, seconds. All right, we haven't done this forever. So here we go. To refresh our memories, we're going to type in 18.775. And then we go to second apps and click all the way down to DMS, degrees, minutes, seconds. And the answer is 18 degrees, 46 minutes, and 30 seconds. All right, so one more time, and we don't need to keep talking about this. You guys need to be practicing and getting it. Type in the decimal, go to second apps, that's your angle menu, click down to DMS. Hit it, got it, right there. Now we're going to actually evaluate some stuff, so we're going to find the sine of 2814. So we have to put in exactly this on our calculator. I want to see that on the screen. So I type sine 28. Now I need to get the degree mark. So I go back to second apps, and it's right there. See it? Press enter, then press 14, go back into second apps. Now you need the minute mark, so you have to go down one, and the answer is 0.4731. Round to the 10,000, that's 4 decimal places.
When will we have to put our calculator in like
Okay,
the
hang on.
mode? Okay.
Yeah, when we look at problem B, do you see any degree marks in problem B? No, that means it's a radian problem. I'm going to skip it because I want to do all the degree ones first, and then I'll come back and do the radian ones. So, C. That's my special cosine button. So I'm going to press second cosine, 0.376, and the answer is 67.9139. And actually that's an angle, that's degrees. So the answer to number 3, C, the answer to C is 67.9139. And you can't miss that if you just type in what it says. Second cosine, 0.376. That's what you come up with. Now, D is a little bit harder. Why is D harder? I do not have a secant button. I spent all this money on this calculator and it does not have a secant button. So what do I type in for the secant of 19?
1 divided by cosine.
Very good. 1 divided by cosine 19. 1 divided by cosine. Whoop. I don't know where I'm at here. 1 divided by cosine 19, and you should get 1.0576. 1 divided by cosine 19. Everybody getting that? Okay, the next one's easy. Cosine 98. Cosine 98 is negative 0.1392. Cosine 98. Oh, the next one's not easy. How do I do the next one?
1 divided by sine.
It's going to be 1 divided by sine. But then I need all this 15 degrees, 19 minutes, 11 seconds thing. So do you remember how to do that? 1 divided by sine. And then 15 second apps degrees, choose the degree mark. 19 second apps, choose the minute mark. And then where do I get that seconds thing? Where does that come from? Alpha plus. And you should get 3.7849. I am rounding to 4 decimal places because that's what the directions say. I'm following the directions. Right? All right, now we did not do B. And we did not do B because it's a radian measurement. So I go to mode, go down to radian, highlight it, and then I type, what is it, tangent 1.15, and the answer is 2.2345. How about that? 2.2345. Everybody okay with that? How did I know that was a radian? No degree mark. Now, look at the very next problem, 10A. Is there a degree mark?
No.
In 10A, is there a degree mark?
Yes.
Yes. So I better right now change my calculator back into degrees, because I'm getting ready to do problem 10A, and it has a degree symbol in it. 10A is a degree problem. Alright, so we're gonna find X. Anybody have an idea how to find X? I'll give you a hint.
-1.
You are going to use trigonometry, either sine, cosine, or tangent. Which one is appropriate for this one? Cosine. Adjacent over hypotenuse. But I'm looking for an angle. So I don't use regular cosine, I use second cosine, right. So second cosine, 11/14. When your X is an angle, you have to use the special button. If your X were out here like on the side, then you'd be using regular cosine. But when it is an angle, you are using special one. So what'd you get as your answer? 38.21? That sound good? I did not type it in, I'll take your word for it. Okay. How about the next one now? Look at it carefully. You're going to pick a function. Sine, cosine, or tangent. Which one is appropriate here? Tangent. Now, second tangent or regular tangent? Regular tangent. Tangent 28. Remember, the angle always goes with the tangent, sine or cosine. So tangent 28 equals 13 over x. How do I do that? Opposite over adjacent. Now, how do I solve something like that?
13 divided by 2.
Well, I'm going to bring the x over here
13 times 2.
and then divide. So x equals 13 over tan 28. Right, what's that one?
24.4.
24.4 or something? Everybody okay with that?
24.
Colleen, you getting that? Scotto? You with the program here? Alright. Alright, now number 11 says, draw a course of 118. Now you guys that have been going on retreat, you missed this part, I think, or maybe not. The rest of us should remember, because we talked about this just a few days ago. What happens if I'm drawing a course? I have to set up my compass. And my compass goes like this. That's the way a compass works. So where would a course of 118 degrees be? Right here somewhere, right? And that's all you have to do. You have to draw in the angle thing, the vector thing, and mark that 118 degrees. That's all you have to do. Okay? But the only way you can screw that up is put it in the wrong quadrant. And as long as you label your compass, you can't go wrong. 118 is between 90 and 180, so we're going to put it in there, right?
Right, so you don't care about using the left side or?
No, that has to be 0. That has to be 90.
Okay.
Yeah, that is the way your setup
So you can
works.
just put it between, like,
Anywhere between 90 and 180. Number 12. Find the exact, that means no calculator, and the decimal value, that means with calculator, for this. So let's do the by hand one first. We're finding the sine of the angle whose tangent is 2/5. All right, we went through this the other day. We said, okay, it looks like a very hard problem, but I always start inside the parentheses. I mean, that's the way math works. You start inside the parentheses. So forget that for a minute, just look here. What does that notation tell me? When I see that notation, I'm over here, right? Now that's positive. That's a positive number. So that tells me I'm in quadrant 1. This is tangent. Tangent is opposite over adjacent, right? Now do the Pythagorean theorem and tell me what my hypotenuse is. A squared plus B squared. What is it? The square root of 29. How did she get 29, kids? 25 and 4? Alright, so that's a beautiful picture. What do I want to know about that picture? What's its sign? Alright? What sign? Opposite over hypotenuse. So that would be 2 over root 29, which is 2 root 29 over 29.
Miss Ford?
Yes.
I want me to go backwards, but are those numbers not in the wrong place?
These?
Yeah.
Not for a compass.
I just said
They're
that.
right for a compass. If you're doing direction, they have to be like that. If you're doing regular math, like regular trigonometry, they go like this.
Got you. Okay.
But you got, they're just different. You got to keep them straight. So this is your compass right here.
Fair enough.
Yep. I wish they were more the same, but they're just not. All right. So now wait, we're not done. This is a two-part problem. First part said work it out by hand. So this is what we mean. Draw a picture, make the triangle, and then do opposite over hypotenuse. Okay? Now go back and just type exactly what you see on the board. So type sine, second tangent, 2 divided by 5. And you should get on the calculator 0.3714. So the exact answer, not rounded off, the exact answer is right here. This is the decimal answer that you rounded off to write down. All right, we're almost done. Jonathan?
Is cosine the only one that has a circle?
Yep. Yep. All right, draw a picture of the following, write an equation and solve it, round to the nearest hundred. All right, so everybody got the directions? Draw a picture, write an equation, solve it, rounding to the nearest hundred. So here we go. Guess what we've got? A squirrel in the top of a tree. I bet he's looking at a nut on the ground. He sure is. There he is. There's a squirrel looking down at the nut on the ground. All right, somewhere I gotta put a 76, a 37.8, and an X. Quincy, what do you do? So where does the 76 go? The top of the tree that's 76 feet tall. Isn't this the tree?
Yeah.
So there's your 76. He's looking at a nut on the ground. His angle of depression is 37.8. Where are we putting those angles?
In the corner, bottom
right
corner.
here, in the corner. I like that. In the corner. That's 37.8 degrees. Find the distance from the nut to the base of the tree. So this is X, right? Got it?
Yep.
Now, write an equation. You're either going to use sine, cosine, or tangent. Which equation, or which one?
Opposite over
Tangent. So you're going to say tan 37.8. Remember, the angle always goes with the tangent, or the sine, or the cosine. So tangent 37.8 equals 76 over x. So x tan 37.8 equals 76. And x equals 76 over tan 37.8. So we're gonna round to the nearest hundredth. 76 divided by tan 37.8. Did you get 97.98? And is that feet? Yep, that's feet. Anybody match that? Okay. Alright, so what do we got now? Oh, we have a seagull. Is he on a cliff or a lighthouse? He's on a lighthouse. So here's the seagull at the top of the lighthouse, and he's looking down at a fish in the water. The gull is 78 feet above sea level. Where's 78 go? Right here. That's how high up he is, right? He is 320 feet from the fish. Where's the 320 go?
Hypotenuse.
Hypotenuse. Very good. There's the gull. There's the fish. They're 320 feet apart. Find the angle of depression. Where does that go? In the corner. Now, wait a minute. What function? Sine, but I'm looking for an angle. So it's special sine, right? I'm looking for an angle. So special sine, 78 over 320, opposite over hypotenuse, special sine. So I get special sine 78 divided by 320, 14.11. And that's an angle, so don't say feet, say degrees.
14.11 degrees.
Got it, folks? Following along? All right, C. How far is an airplane from the airport? Okay, so here's the ground, here's the airport. Somewhere up here is an airplane. And he's gonna land at the airport. So how far is the airplane from the airport if he is currently 6,543 above the ground? And the angle of depression, which I put where? Right there, is 23. Where does the X go? How far is the airplane from the airport? Hypotenuse. What function? Sine. Is it regular sine or special sine? Regular sine. Regular sine. So sine 23 equals 6,543 over x. Right? So x sine 43, or 23 I mean, equals 6,543. And 6,543 over sine 23? Oh, I got a big number, did you? 16,745.53 feet. Almost done. Find the height of a flagpole.
I'm not a giant.
So we have a flagpole. Find the height. Can I go ahead and just mark that X? Find the height of the flagpole. It makes a shadow 31 feet long. The shadow is 31 feet long. That's on the ground. Shadows are on the ground. When the angle of elevation is 29. What function? Tangent. Special tangent, regular tangent. Regular. Tan 29 equals x over 31. So 31 tan 29. That's all there is to it. That's an easy one. I got 17.18. Did I do that right? 17.18 feet. Last one. Here we go. A man looking at the top of a building. So here's the building. Here's the man looking at the top of the building. Where do I put the 84? The building is 84 feet tall. Where do I put the 1, 2, 3, 4? He is standing 1, 2, 3, 4 from the building. On the bottom. Very good. Where do I put the X? Right here. Right? What function? Tangent. Special tangent or regular tangent? Special. I want the angle whose tangent is 84 over 1, 2, 3, 4. So second tangent, 84 divided by 1, 2, 3, 4. Oh, I got a little tiny number. Did you get 3.89?
Yeah.
So 3.89 degrees. Now, one more time, then we'll start the next practice test. One more time. How come we used second tangent on this one and regular tangent on this one? What's the difference? Finding an angle. If X is the angle, you've got to go special. Right? Okay? All right. Let's take a look at page 1 of pretest number 2, because we did this last time we were together, so it's been a long time since we've seen these problems. So let's do these again. We are now on practice test number 2, and we are starting with problem 1, which says change to degrees 7 pi over 10. Now, you have done this a million times. You have changed to degrees. We remember what? Pi is 180. Divided by 10 would be 18. Times 7 is, I don't know what 18 times 7 is, 126?
Yes.
Double check my arithmetic, is that right?
Skills, though.
So again, how did we do that? We know pi is 180 divided by 10 times 7. Bless
Bless
you.
you, Dad.
Yeah, thank you.
Now, what about 200 degrees going the other way? Ooh, this is a little harder.
X over 200 equals.
Thank you. X over 200 equals pi over 180.
Wow.
This will always be in the problem. Then we have x over our angle. All right, so what do I do?
Cross multiply.
180x equals 200 pi. Cross multiply. And then divide by 180. So x equals 200 pi divided by 180. Now you need to reduce that. Look, the zeros are going to cancel. So you have 20 over 18. 2 goes into both. 10 over 9? There's your answer. 10 pi over 9. Number 3, probably one of the tougher ones. Anybody remember how to find the measure of the arc? What'd you say? Arc length equals radius times radii. Is that one of those hideous, like peanut butter and jelly or something things?
I was like, I think you're looking at me. I was like,
Did you see her face, but she said,
Oh, it makes me want to throw up.
Uncrustables?
Yeah.
So good.
Those are fire.
Those are the most disgusting.
What? Do you not like PB&J?
Not.
Who said they
That's
nasty?
so processed
Run
and
it up, bro.
packaged.
What's that?
Marley, you
What's
said
that? What's that?
Don't say that no more.
What did he say?
I said these are better than Precal.
Wow.
put him.
That's an attention right there, guys.
Alright,
So do you know?
I know that my radius is 8 feet, and I know that my angle is 100 degrees, and I want to find the arc. That's this right here. This is what I'm looking for. That's the arc. Now, the radius is 8. That is known, so I'll put that right here. What's the problem? Some of you are going to put 100 up here, and that's wrong. Because while I do want to put an angle up there, the angle has to be in radians. So I'm going to have to do what I just did. I'm going to set up a proportion that says pi over 180 equals x over 100. And I'm going to figure out what the radian measure of 100 is. So pi over 180 equals x over 100. So 180x equals 100 pi. And x equals 100 pi over 180, which is going to reduce to 5 pi over 9. Now, what is that? 5 pi over 9? That's 5 pi over 9 radians. That's this angle right here. But now it's in radians. So I'm going to put 5 pi over 9 here, and now I'm going to multiply. So when I multiply 8 over 1 times 5 pi over 9, I go straight across, so that would be 40 pi over 9. And there's a unit on that. That's a length. I'm measuring that. What's the unit on it? Feet. Feet. Why is the unit on it feet? Because the radius was in feet. And that's going to match the radius. Okay? All right, number 4. Are you ready for number 4? Number 4 says the sign is to yes. Listen, if we don't get this done, you guys have to do it for homework, and you already have a ton of homework due Wednesday, right? Yeah, so let's get it done. Now I need to draw a picture of this, kids. I need to draw a picture. And I'm not sure where to draw it. Can you help me? In between 90 and 180. Now this is not a compass problem. So 90 and 180 are here. So I am going to draw my triangle between 90 and 180 because it told me to. The sine is 2/5. So now I can label some stuff here. The opposite side is 2, and the hypotenuse is 5. Pythagorean theorem. Now be careful. What's this side going to be? It's going to be negative for sure. Very good.
29.
No, it's not 29.
21.
It's 21. Why is it root 21?
25.
Because a squared plus 2 squared is 5 squared, right? This is always c squared. The hypotenuse is always c squared. So you have a squared plus 4 equals 25. That's where the 21 came from. Got it? Now what are you doing? You're finding everything. So you're finding sine, cosine, tangent, cosecant, secant, cotangent. Now, the sine was given, so the sine is 2/5. That's automatic. Everybody gets that point. Everybody should also get this point. Because if the sine is 2/5, the cosecant's 5/2. Those are automatics. Now, what about the rest of it? Well, what's the cosine? Here's your picture. What's the cosine? Let me get this out of here. What's the cosine? Negative root 21 over 5. Which means the secant is negative 5 over root 21. What's the tangent?
Negative 2 root 21 over 5.
So yeah, 2 over negative 21, root 21, which Jonathan has already said rationalizes negative 2 root 21 over 21. And if that's the tangent, then the cotangent is negative root 21 over 2. Got it? Jonathan?
Yep.
Okay. Everybody else got that? A lot of points on that problem, a lot of different answers. All right, find the exact value, cotangent 300. Let's get this part finished. Cotangent 300. Here we go. How do we find the cotangent of 300? Who remembers? What do we need to do? We need what? It's going to be the reciprocal of the tangent.
But you do that little graphing, put it on the 300, bow tie.
I got to graph it, bow tie it.
Quadrant 4.
Because I'm doing this by hand, I'm not typing in my calculator. So I remember that's 90, that's 0, that's 180, that's 270. So where's 300 going?
Quadrant 4.
Over here, right? That's 300. Butterfly bow tie it. Now you gotta figure out this. Now that's 0 and 360. So you gotta go from 300 to 360, so this would be 60. So what are the sides of the triangle?
Root 3.
Root 3 goes over here, 1 and 2. I'm not in quadrant 1, so something is negative. 3 is negative. The 1 is not negative. 1 is positive. You're going right.
Adjacent over opposite.
Cotangent, somebody's saying adjacent over opposite. So that would be 1 over negative root 3 or negative root 3 over 3. Easy enough? All right, B. We're going to find the sine of negative 420. 420? Wait a minute. first of all, negative. What does that even mean, negative?
You go past 360.
Well, but negative means instead of going up and around, I'm gonna go down, right? Negative angle. So this would be negative 90, negative 180, negative 270, negative 360. I gotta go even past 360. How much past 360 do I have to go? 60. So I'm going all the way around and then 60 more, so I'm down here like this. How big's that angle? How much more did I go? 60. That's a 60. So we're right back same triangle we had a minute ago. And the root 3 is negative. It's a little tricky. What's the sign? Negative root 3 over 2, yeah? Negative root 3 over 2. Good work. What does that mean? It means I can only look, I gotta draw a picture. Every problem I draw a picture. But the picture I draw can only be over there. And it's a positive number, so I'll draw it in quadrant 1. And the sign is opposite over hypotenuse. So how big is that angle?
45.
45. What's the answer to the question? 45.
You do what?
Clayton, what do you think about that? Does that make sense to you? You okay? Okay. All right. Angle whose cosine is negative 1/2. All right, so here we go. Where are we going to draw this one? Up here somewhere. Second quadrant, because the number is negative. So the cosine is negative 1/2. How did I know to put the 1 and the 2 where I did? Cosine is adjacent over hypotenuse. So the other side will be root 3. Should that root 3 be negative? No. Way up. How big is this angle though? 60. The answer is not 60. It is not negative 60. This is
120.
the answer.
No.
The answer is 120 degrees. I want to do 3 more problems here. Then I'm going to let you graph on your own. Here we go. Ready? 3 more. Here we go. Tangent 7 pi over 4. All right, what are you going to do with this one? Tangent 7 pi over 4. What? Yep, you're going to do 180 divided by 4, or 180 divided by 4 is 45, times 7 is 315. So this is 315 degrees. And I will let you use a little scientific calculator if you have one. Not a grapher on this part, but use a little Little one if you have one. Or you have to do it by hand like I do, it's fine. Tangent 315, what do? We draw it. Where is 315? Wouldn't it be over here? That's 315. So we butterfly bow tie it. That's a 45-degree angle because you got to get from 315 up to 360. What are the sides? 1, 1, root 2. What's negative? They're going down, negative, or 1 is negative, that one's negative. Now we want the tangent. So we look at our picture and see opposite over adjacent. Right, kids? Morgan, opposite over adjacent. So that would be negative 1 over 1, which is negative 1. All right, cosine 3 pi over 2. John, how you gonna start? What are you gonna do? You certainly do. And what is 180 divided by 2? Yep, and then what do you do? Yep, what's 90 times 3? You got it. Cosine 270, very good. Thank you, perfect, beautiful. Oh no, though. Oh no. 270 is here. I cannot butterfly bow tie it if it's on a line. So I gotta think about the circle with a radius of 1 and figure out what that point is down there. So here's the origin, and I'm going down 1 unit. 0, comma, negative 1. So x is 0 and y is negative 1, because that's that point. X is 0, y is negative 1. Cosine is x over r. So r is 1. Remember, we got the radius for 1. So x over r is 0 over 1, which is 0. Remember, 0 over 1 is 0, and 1 over 0 is undefined. Kelly Berry, you with us? Okay. All right, one more. In which quadrant is the cosine negative and the cosecant positive? So cosine is negative, less than 0, negative. And the cosecant is the same as the sine, is positive. So I want the sine to be positive, because sine and cosecant are reciprocals, right? So I want the sine to be positive and the cosine to be negative. Can that happen in quadrant 1?
No.
No, because nothing's going to be negative in quadrant 1. So let's just go to quadrant 2. If you butterfly bow tied in quadrant 2, that's always positive. That would be positive and that would be negative. Now, is the cosine of this picture negative?
No.
Cosine.
Yes.
Adjacent over hypotenuse. Wouldn't that be negative? What about the sine? Opposite over hypotenuse, would that be positive?
Yes.
So the answer is again quadrant 2. The answer will not always be quadrant 2. It just so happened that worked out. All right? Now, you may leave the room after you have done number 7, number 8, and number 9. It's fast. 8 and 9 are calculated things. You can fly through those. Okay? So you may leave after you have done those. I'm going to go ahead and do them on the board. so you can check your answers. But try not to look up here. If you're not getting what I'm getting, then this would be the perfect time to ask me, since you know these questions are going to be on your test. All that giggling that's happening back there, I hope there's some math going on.
Alright.
There you go.
You can't be done already. I'm not done yet. You can't beat the teacher.
Huh?
Yeah, some of you racing.
No,
Joseph, take your hood off. I've done the graphs, so if you want to look up there and see, make sure you're filling in amplitude and period too, guys. Make sure you're doing amplitude and period. That will be points on the test that you'll want to take advantage of. Doesn't say to round two.
Shows we have to do two.
Got a Charlie horse?
Shows we have to do two. Already through nine.
Charlie on a horse is actually Charlie's riding your
On the test, would these gonna be graded for the graph or for the amp?
Everything. Everything's worth points.
How you convert some
now, bro. You gotta
How you convert some of the degree sometimes?
You change it to degrees. Change the degrees.
If that, whatever you guys are doing spills, I'm gonna do something awful.
Joseph James.
What? Oh, wait a minute. Wait a minute. That one.
You're shaking.
This is Okay. Yep. All right. If you got what I got and you're comfortable with that, run it up. Let me see that you did the work. And then you are free to go. So I need to see you did the work, filled in your amplitudes and periods. You got everything I got? Check your answers for mine. Sure. Okay, now this is not a good cosine term. Here's what cosine comes. Oh, that's not even supposed to be cosine, that's a sine. The sine starts at the origin. The rest of it's right. Alright, there's all match line. Alrighty. Okay, John, how'd you do? Looks good. Hey, you're not done here, dude. Go sit down and do those. Yeah, you need to do those. You need to do all that. Everybody doing okay with the graphs? Okay. Graphs, you doing okay? Okay, let's watch our tangents and make sure, first of all, that's a negative tangent, so it's going to go like, okay, because it's negative. A positive one is going to come like that. All right, so watch your curvature a little bit. Okay. Alrighty. Here we go.
I might do rugby.
Rugby's an awfully difficult sport on your body. You get beat up big time.
We have 3,000.
I saw my papers on.
Sign my paper. Sign my paper.
You're a changed man, remember?
Hey, don't run up on my boy Roddy like that.
He ran up on me.
He's allowed to. Since he ran away, he's actually a man. He's not a change man. He claims he's a change man.
This would this for this one. Did you put it in
That's how we use the system.
This one's not
Call for ball.
okay.
And you say,
Johnny, all right, you know how to do all this curve? Always divide.
All right, well. Yeah, cuz. So get on, skedaddle, kick rocks, Arriba Dirk Kick.
Because that's supposed to be 90 divided by a half, okay? Be careful. How do you do, sunshine?
Oh, I hit my head.
Did you turn it on?
No, hold on, cuz.
Hey, about you.
This has been brought to you by Lisa Ford.